Okay, let's keep going. Work energy theorem. So it says down here, a rifle can shoot a bullet that has a mass of 4.77 grams at a speed of 655 meters per second. Now, if the work done on the bullet over this distance of 1.25 meters, what is the average force? Okay, so in this case, when you're given all of these variables, it's probably going to be the work equals kinetic energy. Okay, or we can change this up to say work is force times distance equals 1/2 mv squared. I'm actually looking for force. The distance is 1.25, 0.5. The mass, grams is not a good number. So I'm going to come over here and I'm going to say King Henry drinks utterly delicious chocolate milk. 1, 2, 3. 1, 2, 3. 0.0077. 0.004. I'm sorry. 0.00477 times the velocity of 655 square it. Divide by 1.25. Cancel. Divide by 1.25. Go ahead and find your answer. And the SI unit is a Newton. Okay. So again, you're going to use that equation, it looks like, probably for the next couple of questions as well. Let's keep looking. The law of conservation of energy tells me the amount of energy I have before must equal afterwards. So don't forget, over here at the top of a roller coaster, before the roller coaster starts to move, all of the energy is potential energy, because what is the velocity? 0. So mathematically, my kinetic energy is 0. But when my object's on the bottom floor, on the ground, what is the height? 0. So the potential energy is 0, but all of the total mechanical energy was converted from potential to kinetic at this location. Now at the halfway mark, they're telling me it's halfway compared to this. If this is h and this is half of h, then that means that this amount of energy right here, 275, which is my mechanical energy, is going to be divided in half, and it's going to be 137.5 and 137.5. They're both going to get some, as long as the mechanical energy total is going to be the same throughout the whole roller coaster. We had this practice problem. Let's go ahead and practice them again, though. Step 1, they gave us the mass and velocity of this kid as he's driving up here through the ramp. Now, at the moment, though, his height is 0 meters at here. So that means that his potential energy is 0 joules. So his kinetic energy, which is Ke equals 1/2 mv squared, is going to be 0.5 times 62 times 12.5 square. So go ahead and find that number out. 0.5, multiply it by 62 times 12.5 actually comes out to an answer of 387.5 joules. So that means that this number is going to be the total mechanical energy at every location. So let's go ahead and let's continue. At this location, he's 1 meter above the ground on the ramp. I don't know his velocity, but they want me to find it. But the fact that I have the height, that means I'm going to start off with GPE. So GPE equals mgh, or 62 times 9.81 times 1 for the height. So 9.81 times 62 times 1 comes out to 608.22. And for those of you who are watching, did you notice that I forgot to square this? Forgive me. I told y'all I'm human too, and my weakness is I always forget to square the numbers. So I re-multiplied this and I found out that this is actually 4,843.75. It just did not make sense a second ago. 7.5 joules. There was no way I can have more energy here than over here. So there's the real answer. I forgot to square it. But for the kinetic energy, so 608.22. If I know that the total mechanical energy is 4,843.75, if I subtract the potential, I'm going to get the kinetic. So let's subtract 608.22, and I'm going to get my kinetic energy of 4,235.53. So 4235.53. Well, now what's my velocity? Well, in that case, we're going to go ahead and use the KE equation. And since I know the KE value, KE equals 1/2 mv squared, or 4235.53 equals 0.5. The mass is 62, and then don't forget to square root the velocity. So 62 divided by 2 is 31, or 62 times 0.5, which is the same thing as divided by 2. So 31 on this side, that cancels. Get that number divided by 31, you're going to get a number. Okay, so divided by 31, I get 136.63, not my answer because I need to square root this number. So once you square root it, then you'll have your answer. Go ahead and complete and finish that. We did the roller coaster. I talked about this question on every single class because I wanted to make sure that we talked about it. Please use this same concept for over here, okay? If it's not drawn proportional, it's not drawn proportional, but still go ahead and plug in that information. The next thing, we have some vocab words. Here's the word bank to answer the questions. I think you should be completely able to answer that page. Now, the last page is, because we're going to have a couple of these on the semester exam. Let's go ahead and make sure that we use the correct colors. So on semester exam, make sure you have your ruler because you're going to need to find the wavelength measurement, and you're also going to need to make sure that you color it. I will have plenty of colors and matte pencils there for us in class that you can use, okay? But don't forget, the number one mistake that I did see from students was actually trying to find the frequency, because step one was the frequency is 1 over T. Well, I don't have T, so I'm going to have to use the number of waves over the total amount of time. So for an example, this is 1, 2.5 waves. So 2.5 divided by 2.25 equals 1.11 hertz. Now that's my frequency. Part 2 is the velocity of the wave equals the frequency times lambda. You're going to get that number, 1.11, multiply it by the lambda, which is going to be the wavelength from here to here. What is that distance? So now get your ruler out, measure that, so that way you can find that distance for the lambda. Okay? We just went over that. I gave you the answer key. Please, I hope this helps you a little bit. I'm not doing all of it because I need you to work on some of it on your own. Okay? Let me know if you have a question. Have a good day.